are starting off with oxidation and reduction. Oxidation is releasing electrons by a certain atom, and reduction is gaining electrons by a certain atom. During oxidation, the positive nature of the atom will increase, and during reduction, the positive nature will reduce. That means it loses more electrons, and this doesn't lose electron, instead it gains the electron. For example, if I take Fe2 plus will oxidize to Fe3 plus, which means from plus 2 it have gone to plus 3. By losing an electron, positive nature have got increased. It is less positive because it is gaining electron. For example, if I take copper 2 plus, it will turn into copper. That means from plus 2 it have gone to 0, which means the positive nature is reducing, decreasing, because it gains electrons. So when a species undergo oxidation, the other species will undergo reduction simultaneously at the same time. That means if I take x plus y forming xy, if this species is undergoing oxidation, it loses one electron. This will undergo reduction. These processes happen simultaneously, that means at the same time. Therefore, here the oxidation is known as the reductant. That means the reducing agent. And Y is reduction, that means it is known as the oxidant. Also, we can call it as oxidizing agent. The reason we gave this term for X and Y is reducing agent will make the opponent cause the reduction reaction, and oxidizing agent will cause the opponent oxidation reaction. This is how this works. So the species undergo oxidation is reductant, and the species undergo reduction is the oxidant. Once again, let me repeat this. Oxidation will lose electron and make the other species to gain electron, and reduction will gain electron and make other species to lose electron. It's like this. The person who gives money is oxidation, and then the person who takes money, now let me take another example. Here the zinc is losing 2 electrons and becoming zinc 2 plus. Now this is the normal atom, and this have given to means it has lost 2 electrons. So that means if it loses electrons, it have undergone oxidation reaction, which means it acts as reducing agent. Copper 2 plus, they gain electron and then they become copper back to normal. Therefore, here the reaction occurring is called as reduction, which means it acts as oxidizing agent. Simply to understand this easily, oxidizing agent will make the other species undergo oxidation. Likewise, the reducing agent will make the other species undergo reduction. An atom can never undergo oxidation or reduction independently on their own, because they are simultaneous processes. During an oxidation, the electron release should always definitely be used for a reduction. The example says sodium plus chlorine forms sodium chloride. Sodium will lose 1 electron, so that means it undergoes oxidation. So if I take that reaction, sodium will become sodium plus because it is losing one electron. Now here if I take chlorine, it have got electron, that means it have gain. So chlorine plus the gained electron will form Cl minus. Here losing electron means this is going to be oxidation and gaining electron means this is going to be reduction. Sodium is becoming sodium plus and chlorine is becoming Cl minus. Balancing redox reactions. Uh, Here, first of all, we are going to focus on steps to balance half reactions and then the redox ionic reactions. There are 5 steps. Step number 1 is we have to balance all the atoms which have oxidation number that changes. Here there is an exception. When they say all the atoms, it should be all atoms, but except hydrogen and oxygen. Step 2 is, third step is, we have to balance charges. When balancing charges, according to the medium, H plus OOH minus should be added, thus to the suitable sides. The fourth step is to balance the number of hydrogen atoms, we add water. Fifth step is we have to just check if the oxygen atoms are balanced or not. That's it. Now let me take an example. Now step number 1 says balance all the atoms having oxidation number that changes. We shouldn't look at oxygen. First of all, let's balance this. Here there are 2 chromium, so I'm adding 2 in front of this chromium. And the oxidation number of chromium here is plus 6. And there are 2 chromiums. Here the oxidation number is going to be plus 3. And here also there are 2 chromiums. Here there is exceptional case that we should not consider hydrogen and oxygen. So here the oxidation number that changes is chromium. To balance this, we have to find the change in the oxidation number. So what's the change in the oxidation number? It is 6. Therefore, we have to add that many amount of electrons to the side with higher oxidation number. So this is the side with high oxidation number, here plus 12 and here plus 6. So I'm going to add 6 electrons to the side with high oxidation number. Now balance the charges. So when balancing the charges, according to the medium, we are going to add H plus or OH minus. H plus in the sense acidic medium. OH minus is for basic medium. Therefore, now by adding H plus or OH minus, the charges will be balanced. So here I'm going to add H plus. And then to balance the hydrogen, I'm going to add water. So it's going to be 14H plus and 7H2O. Now check if the oxygen atom is balanced. Yes, 7 oxygen atom here, also 7 oxygen atom. Now this is all about this reaction. Moving on to the next. So if I take this reaction here, the same steps have to be followed. We have to balance the atoms having oxidation number that changes, except hydrogen and oxygen, so we shouldn't consider oxygen. So the atom that changes the oxidation number is manganese. Here the oxidation number is plus 7. And here the oxidation number of manganese is plus 4. And then we have to find the change in the oxidation number. Here the change is going to be 3. After that, we have to add that many electrons to the side with higher oxidation number. So this is the side with high oxidation number. So I'm going to add 3 electrons. Since it is basic medium, to balance the charges, I'm going to add OH minus. To balance hydrogen, I'm going to add water. So if I balance this, it's going to be 4OH minus and 2H2O. So that's all under half reaction balancing. This is how we balance the half reactions.